Thank you everyone for joining us today. We're really excited to launch our WaterWatch software and share it all with you. I'm Kendra Olmos. I'm the Executive Director for the Center for Water Energy Efficiency here at UC Davis, and I'll be your host today. We are expecting a diverse audience from both the water and the energy sector. So let's go ahead and start out with a brief poll. Okay, while you guys are doing that, we'll go to the next slide. So just a real brief introduction on our center. We are an academic research center that focuses on advancing water management solutions in the 21st century, and our focus is on the water, energy, and climate nexus. Actually, should we go ahead and look at the results of that poll? Sorry about that. Wonderful, we have a little bit of everybody here today. Again, thanks for joining us. So this project, developing WaterWatch software, was actually funded by a grant with the California Energy Commission to advance energy demand management in the water sector. And we had a few partners. Molten Niguel Water District was our utility perspective and our piloting test site. And then we also worked with California Water Efficiency Partnership and the Alliance for Water Efficiency to provide outreach and dissemination. Our original objective in building this software was to provide a means for water distribution systems to better manage their energy load, be able to shift it across different energy rates or energy demand management programs. But what we ended up building is a tool that's far more comprehensive and allows for resource management at utilities in terms of operations and planning. Next slide. So we are going to present the software for about 35 minutes and then invite our partner, a couple of folks from Molten Niguel Water District, to give a brief discussion about their use and user experience of the software. And then we'll have a question and answer with all three of these speakers. And go ahead, as we're going with the presentation, submit your questions in the question and answer section as opposed to the chat. And I'm going to go ahead and present our three speakers. Robert Good is the lead developer and engineering manager of WaterWatch software. His research interests include optimization and automation of water distribution networks and real-time data visualization. Lindsay Stuvik manages the Water Efficiency Department of Molten Niguel Water District and serves as the co-chair of the business development team for the California Data Collaborative. She is also the recipient of the Switzer Fellowship from the Robert and Patricia Switzer Foundation. Dan West is the superintendent of operations at Molten Niguel Water District, managing the customer service field and leak detection crews. His experience includes holding the positions of Chief Water Systems Operator, Water System Operator, and working on maintenance and repair crews. And I will go ahead and let you take over, Robert.
Perfect. Thank you, Kendra, and good morning, everyone. My name is Robert Good, and I want to walk you through what WaterWatch is, why we at UC Davis decided to create it, and then I'll demonstrate examples for how your water system would utilize WaterWatch to answer realistic, interdisciplinary questions in an extremely short amount of time. I hope that you find today's presentation intriguing as a potential tool your agency would benefit from. If you think your agency might be interested to serve as a test site for this software, please reach out to Kendra or send an email to our center for further information. Today, water agencies are investing tens to hundreds of thousands of dollars into hydraulic models that can simulate your water networks. Often, these models are built for capital improvement, pressure or fire flow analysis, and other one-time questions. But how many water agencies have invested in these tools only to see them utilized by one group within your agency? How many agencies have allocated 1 to 2 specialists in your entire organization to their hydraulic models? Or how many agencies have not utilized these models for months to years after their creation? And then by the time that you need it again, it needs to be calibrated or rebuilt, and the cycle repeats. This is a missed opportunity because we know that hydraulic models could be used to support nearly every part of your agency. Operations could check the impact of changing pump schedules. Engineering teams could prioritize preventative pipe replacement strategies. Accounting and operations could collaborate and work together to find the energy tariff rates which save money and can be easily shifted into. Conservation teams could standardize how they calculate energy intensity, carbon emissions, leak loss, and more, down to the individual customers and zones. The list of benefits could go on forever. But today, hydraulic models require expertise or at least experience to run, debug, and understand their tools. They lend themselves to your engineering and GIS departments and less to your operations, conservation, or accounting activities. We believe that hydraulic models are not serving you as well as they can or at least should. So in response, we sought to build WaterWatch as a tool to extend the life and purpose of your hydraulic models to further benefit your entire water agency for years after its creation and calibration. Specifically, what we believe was needed is a support tool for water agencies that could be used by their planning, operation, engineering, and management teams. Now, that's a fine description for most of our audience today, but there's a few of you here with experience in hydraulic modeling, I'm sure, who may want to know more about what we did to make WaterWatch different in the realm of hydraulic modeling. For those people, here's a short list of features you may already be thinking about. First, we needed a tool that could retain weeks, months, and years of simulated and historical data, including simulations and SCADA, in memory without utilizing a database. We also needed a tool that could report results using real dates and real times throughout, without referencing indices or EPA pattern formats. The tool had to automatically simulate without you needing to press play after every change and could keep up with reality. We needed a tool that allowed operators to override a pump or a valve's control for only an hour or two without dealing with complex logic or rules and if-then statements. We knew that a major gap in hydraulic models is when simulating pumps or valves that are manually controlled and for which there does not exist any if-then logic that could be used to model them in traditional ways. To solve this, we knew that we needed a machine learning directly integrated into the hydraulic model. We knew that water agencies needed to perform significant multitasking and want a tool that can do everything simultaneously, from machine learning to viewing SCADA to creating optimizations and more. We needed a tool which could incorporate customizable PID, proportional integrative derivative algorithms, to better reflect those seen and used in reality. We needed a tool which could automatically stream in and match current SCADA and billing data from the field. The tool needed to automatically detect and report district metered areas, pump stations, and more to integrate those into the model. And when it comes to optimizations, we knew from interviewing operators that most water agencies did not benefit from short-term optimizations, which are invalid the moment your operations deviate, even slightly, from the prescribed schedule. So we needed a tool which generated long-term operating policies as part of any optimization to ensure they were safe, reliable, and human readable. We knew that water agencies want to compare what-if scenarios without needing to manage their simulations. We needed a tool which automatically keeps scenarios up to date and can compare their performance and assets for any time period on the fly. To address all of this, we built WaterWatch from the ground up using a custom high-performance data engine as a standalone and on-premise solution for Windows 10 desktops and tablets. This means it safely functions within your existing securities and firewalls and does not export your model or your data out into the cloud. Let's spend a minute to explore WaterWatch and begin to see what I'm talking about. Once open, we can either import your existing hydraulic model using the common EPA-NET format, or we can resume an existing WaterWatch project. Let's go ahead and load today's project. This project represents one pressure zone from a real water system. Each WaterWatch project includes the hydraulic model, all the scenarios, SCADA and billing data, and much more. This is the main landing page or home page of WaterWatch. On the left-hand side of the screen are shortcuts to the most common features, including dashboards, maps, options, and much more. In the center of the homepage are a list of pages or features available in this project. At the top of the screen are the list of pages we've already opened and can return to or close at any time. Let's learn a bit more about this pressure zone by opening the SCADA Plus dashboard. This dashboard is automatically generated by WaterWatch after analyzing your hydraulic model. Notice that the left side of this dashboard informs us about the current activities of this water system and displays a collapsible list of pressure zones. Now, I've renamed these zones and assets, but WaterWatch automatically detected these and occupied them with only the assets that it believed were critical to the operation of this zone. It automatically combined pumps into pump stations. It automatically identified system connectivity, distributed areas, and water flow. Knowing that, anyone from your water agency could quickly review this dashboard and understand which zones have water storage, what the status and drain rate of that storage is and the flow through any pump stations. Using the figures in the middle and the right, anyone from your agency can quickly appreciate the next 2 to 5 days of operations, including your total water storage, forecasted water demands, and the resulting energy demand from your pump stations, and key performance indicators, including the capacity of storage, elevations, carbon emissions, and more from your energy supplier. Now let's go ahead and see a bird's eye view of this pressure zone using the service territory map. I can quickly switch to this page using the hotkey on the left side panel. And in this page, we can see a layout of this water network and use GIS style tools to change the visuals of this map. Since it will be focusing on this pressure zone for today's presentation, I want to highlight the 2 pump stations that are available to serve this zone. And downstream, we can see the storage tank highlighted here. Surrounding the zone is a dark outline. This boundary was determined by WaterWatch automatically. Each virtual district metered area in your water agency is detected and automatically receives their own boundary using this tool. The same is true of pump stations. Here, this northern pump station is identified by a surrounding purple hexagon, which WaterWatch is drawing around these 2 pumps that we see here. For this map, it is clear that this pump station is lifting from a nearby tank. The same is true for the southern pump station. Lastly, I want to point out that this zone has a good range of customer elevations served within it. To help visualize this, I'll quickly use WaterWatch to generate a new background based on a heat map of customer elevations. Here, I'm hiding the pressure zones, then I am disabling the satellite imaging. Then I will ask WaterWatch to generate a dynamic background based on a variety of characteristics or colors of my choice. For now, we will choose elevation. With only 3 or 4 clicks, I can generate an entire 3D surface of our water system, which takes every single junction, pipe, and more into account. Once generated, I can clearly see how there is a valley of lower customers surrounded by 2 hills. We will revisit this soon when discussing pressure. We can see that the map remains 3D at all times, allowing for a very natural experience when making visualizations or animations, which I'll show off later. Now, at this point, everyone here today should have a general idea that WaterWatch is essentially a plug-and-play tool that allows you to use your hydraulic model to easily and quickly create visualizations and dashboards while fixing some of the major gaps that current hydraulic models have. To further explore WaterWatch, we will give 3 concrete examples of how this tool could be used by your water agency's teams, using this pressure zone as the subject. The first will demonstrate using WaterWatch to research pressure management strategies. The second will demonstrate an operator creating a strategy for energy load shifting in real time. The third will explore cost-saving maneuvers that the water agency could make while maintaining safe and reliable storage. But before each of these examples, we want to perform some community engagement. So let's take a poll. Allie, if we can start with the second poll. Using this poll, we want to have an idea of how interdisciplinary your water agencies already are before we move on to the following scenarios. We'll go ahead and give everyone a few seconds to fill this out. All right, let's go ahead and take a look, Allie.
I'm going to give folks another second. I can see them rolling in right now.
That's perfect. Thank you. So it looks like about a third of our participants today have excellent cross communication between their teams. And then it looks like the remainder range between only for data gathering, like for production data, or never. So for the large majority of those here today, this will be a meaningful scenario to pay attention to. Thank you, Allie. Now, for those here today that do not interact with your engineering or operations teams as often as you would like, here's a quick example of how you might interact if you had access to hydraulic modeling insights through WaterWatch. In this first example, imagine one of your conservation or efficiency staff want to start a conversation with operations on how to reduce pressure in your system, but you don't have experience with hydraulic modeling. Is this something that WaterWatch could be used for or make easier? Let's take a look. To start, let's characterize the range of hydraulic head and pressure in this zone. For this, we'll use the service territory page, as we showed earlier, to generate some quick visuals. I set this map up to colorize junctions based on their hydraulic head. Using the legend in the top left of the map, I can see that the pressure is shaded from dark to light. And looking at the map, I can tell that the southern part of this zone likely has a higher hydraulic head. But what of the pressure once you subtract out elevation? Well, let's generate another shaded background based on customer pressures. Just as before, I'm going to hide the satellite imaging and generate a new background. WaterWatch uses its data engine to quickly analyze every latitude and longitude in and around your system to determine how to best draw these polygons, when they stream the results directly into the map's background to generate a new interesting figure. And just like that, we have made a 3D rendering of my zone's pressures. Let's go ahead and zoom into this map and see where we have high and low pressures and what those pressures seem to be. On the left here, I can see a bright area indicating higher pressures. On the top right, I can see a darker region indicating lower pressures. Selecting one of the assets in the map, a panel on the right-hand side opens up, allowing me to gather as many assets as I want for editing or viewing purposes. Here, I can collect some of the higher and lower pressure junctions until I believe I have a good understanding of the range, as well as where the max and min is located. Within 1 minute, we have found these critical junctions. We know that the high pressures in the zone can be near 160 psi, whereas the low pressures can be closer to 50 or 40 psi. The perceptive people among us today may have already noticed in the legend that the minimum pressure is around 7 psi. That would be the suction pressure behind our pumps, so we can safely disregard that now since we're focusing on the downstream pressure. Next, let's take a look at the SCADA Plus page to review the operations of the storage tank in this zone. Here, in the top middle figure, we can see that the water storage trends between 1.6 to 2 million gallons. Using your mouse or pen, we can quickly hover over most figures in WaterWatch to have it tell us the value in time at that location. Here, I can see the precise fill trends. In the bottom figure, we can see the energy demand from pumps filling our station. Notice that we are filling to simply keep the reservoir at around 88% full, while of course avoiding the peak energy price period between noon and 6 p.m. We learn a bit more by clicking on the tank and pump station icons in the list on the left-hand side. First, notice that we are now seeing a longer trend for the storage tank. Here, the y-axis is our storage level, and we are looking at the past 24 hours, a vertical dashed line representing the current time, followed by an upcoming recommended storage levels for the following 5 days, generated by our tool. Then we can click on the pump station to see their flows, which vary between 0 to 2,000 gallons per minute, and their energy demands at about 1/10 of a megawatt. We notice that each pump station is following the same on-off logic, but we also note that the northern pump station seems bigger. It has a higher flow and a higher energy demand. We will take advantage of this shortly. With all of that groundwork, what do we know? Well, we found out that this zone uses 2 pump stations, activating and deactivating to maintain high storage levels while avoiding the peak price period. We know that the most northern customers have the lowest pressure, and we would probably benefit from focusing on reducing pressure in the southern part of our zone. Lastly, we know that the storage levels are kept on the higher end of the tank's capacity. So what are some strategies that we could test? Well, based on these intuitions, for this example, we'll try 2 things. First, we will see what happens if we deactivate the southern pump station entirely. Perhaps the northern pump station can keep up with water demand itself. Second, we will see what happens if we instead exchange one of the northern pumps with a variable flow drive pump and maintain a reliable but lower tank level. Intuitively, I think we can all guess that these changes might impact the pressure, but by how much and where? Let's find out. Let's start by turning off the southern station. We'll use this opportunity to introduce how WaterWatch handles the what-if scenarios. Using our scenario builder tool, we can see a list of scenarios. Right now, there is only the one. It is characterized by a name, color, and icon, which we'll take advantage of soon. In WaterWatch, scenarios can be tagged as baseline, favorite, active, and reality. The 2 that we care about for today's presentation are baseline and active. Baseline will be used for comparisons. How do you know a scenario is better or not? By comparing it to the baseline. And active determines which scenario we're viewing throughout the application, such as at the SCADA Plus and service territory pages. Now, let's copy this current scenario and edit how it runs. Once copied, we can then edit this scenario to help distinguish it later. Let's go ahead and change its title, subtitle, icon, and color. Now, while I'm writing these details, I want to clarify how WaterWatch handles scenarios a bit differently than other tools. In WaterWatch, we are constantly keeping these scenarios up to date and performing simulations in the background. That means that the moment I make any change to this scenario, big or small, you will see the ramifications within moments to seconds. You'll understand what I mean in just a moment. The icon and color will help distinguish this scenario. With that done, let's now deactivate the southern pump station. What is important is that the zone has 4 pumps inside of 2 pump stations, all operating to some programmable logic. But instead of modifying that logic directly, we will simply deactivate the pumps entirely. Then we will immediately return to the SCADA Plus page and notice that we can watch the simulation in real time. Also notice that since the active scenario changed, the title and color at the top have changed. We can then review the scenario to our heart's content to see what this did. The key takeaway is that the northern pump station can, in fact, maintain these storage levels, which we can see here. It seems to do so by running for longer hours, but perhaps this is worthwhile. Before we find out, let's go ahead and make a variable flow drive station. We will start by copying the original scenario once more. We'll skip the editing that you already saw and show you how we set up a variable speed pump in our system. Here you can see, excuse me one second here. Perfect. So we're going to go ahead and copy the original scenario once more. We'll skip the editing that you already saw and show you how we set up a variable speed pump in our system. Here we can see that all I've done is set the color of the scenario to purple, deactivated every other pump, and added a new PID style control for how the speed of this northern pump is determined. Here we will inform WaterWatch that we want to keep the storage tank at 17 feet. We set the minimum and maximum settings as well as a coefficient to determine how fast this algorithm should respond to changes. You can, of course, tweak these settings until you achieve exactly the type of reactions that you expect from this pump. As an example, we can go back and forth here as we test changes to these coefficients, resulting in different water flows. And every time I change the controls, the hydraulic model knows to update and does so. By the end of these iterations, let's say that I found a combination of settings that I like. We can then compare these 3 scenarios to see what we can learn. For that, we'll use the Scenario Explorer tool. Opening the Scenario Explorer tool, what we find is our current collection of scenarios, automatically evaluated for their net energy cost, water storage, and other key performance indicators. Importantly, because these are often apples to oranges comparisons, we can see that it allows us to generate a ranking based on our own preferences. At the top of the screen, we see a table of performance values, and we see that the top scenario is currently the one without the southern pump station at all. Looking at the average customer pressure, we can see that the variable flow pump only reduced pressure by about 2 to 3 PSI on average. Looking at the water storage across the 3 scenarios, we can see that this was achieved through the reduction to the storage level itself. We can then compare how these change the hydraulic head at the highest and lowest elevation junctions. Here, we see that even though our top scenario, the green one, barely changed the average pressure, we can clearly see that we reduced the diurnal peak pressure at the highest customers by nearly 20 feet. This is exactly the result that we were after. Now, our conservation staff member has an idea that doesn't impact customers with already low pressures, but it does seem to remove excess pressure from high elevation customers. And they believe it can be done without using new equipment. I think that's a great conclusion for 5 minutes of work. Now, let's pour some cold water and all of that excitement there and move on with our third poll. So Allie will go ahead and get this started. Our next scenario has to do with energy load shifting. So this poll does too, tangentially. So we'll go ahead and give everyone a moment to answer this poll. And once you think everyone's answered, Allie, we'll go ahead and review the results. Beautiful. So it looks like there's a little bit of a gap. Either water systems are about 1/5 of water systems are all the time dealing with time of use, energy load shifting, energy rate programs. And then there's a gap between those who either only do it occasionally to never. That's really interesting. So for many of the utilities today, they would benefit from participating in time of use rates or using this tool to help make recommendations for their active participation. Thank you, Allie. Let's go ahead and get started with our second demonstration. This will be a straightforward and short example, but I'm particularly proud of this one because it involved a great deal of invention and low-level optimizations to achieve. In this example, we're going to assume that your operations staff have been tasked with less than 24 hours notice of an upcoming shutoff to your electricity supply for a 12-hour duration. Many operators may leverage spreadsheets to help with this challenge, but the infinite combinations of weather, water demand, current storage, and more may make it challenging to have an accurate response plan. Obviously, hydraulic models would be helpful if they were faster and easier to use for these type of applications. Let's take a look at how WaterWatch could be used. One second here as it loads the video. Oh, I am experiencing technical difficulties. Please give me one moment here. So it looks like I've crashed PowerPoint. Hopefully not everyone here has experienced that. It'll take me 1 minute to resume to where we were just a second. It's not a webinar if we don't experience bugs and challenges. Perfect. So we'll go ahead and resume to where we were. Okay, I will start by returning to our scenario builder. One feature we didn't show off yet is our cold storage system. Remember when I said that WaterWatch keeps every scenario up to date? Well, the exception is any scenario placed into our cold storage system. When it's there, they are not used anywhere else in the engine. This is helpful to reduce clutter and to reduce the amount of work WaterWatch must do if you don't need those scenarios anymore. Once the scenarios are in cold storage, we create a copy of our baseline. You've already seen how to edit the scenario's appearance, so we'll go ahead and skip that. I've now colored the scenario pink and dubbed it our load shifting scenario. Very clever. Now I will introduce what we call the manual control page, where we allow the user to take the steering wheel and tell the hydraulic model exactly what they want to do. From the left side navigation panel, I select the manual control page. Once here, we're presented with a dynamic matrix of historical and future control recommendations for key assets in our system. At the top of the screen, we can see various dates and hours that we can scroll through. To the left of the screen, we can see the list of assets that WaterWatch knows are critical to operation. We could add or remove assets to this list in the scenario builder if we needed to. In the center of the screen, we can see an editable and live matrix of historical and future controls. Now, when I say editable and live, let me show you what I mean. Here, you can see me turn off and on various pumps at various times, then watch as my future recommendations change according to my choices. In this short amount of time, WaterWatch digests my requests, begins updating my hydraulics, and reports results to me while still in the middle of its calculations. I do not need to wait for an entire simulation to end. I can see the result as soon as it is available for any asset. I can scroll months to years backwards in time, or up to a week into the future. Every single asset is editable for every moment in time, meaning you could scroll back to January, change a pump from on to off, and watch as that cascades up to today. Now, for today's example, we'll start by undoing our changes by simply reverting the red overrides back to normal. Again, notice that no matter how or where I make my changes, backwards or forwards, the response is immediate. Feedback and real-time interactivity is important to me, and it is central to WaterWatch's mission. For this example, we will shut off all of our pumps for a 12-hour period starting at 7 a.m. the next morning. Notice that as soon as I make these changes, WaterWatch initially turns on the pumps later to try and maintain my storage levels. We're going to continue overriding until we're completely satisfied. As you're already aware, these changes are immediate. We can, of course, go to the SCADA Plus page to review the resulting water level for our storage tank. As an operator, I need to determine as soon as possible if I have enough storage to get through this event, or if I need to request access to a diesel generator on site. Looking at this forecast, I can tell that we would, in fact, be able to make this 12-hour period without any pumps. However, let's say that as an operator, I'm not comfortable with how low this tank gets. We can, of course, navigate back and forth, demonstrating one of the strengths of WaterWatch. We can begin to pump earlier, look out for overflowing, and eventually find a sequence of pump schedules that I'm completely satisfied with. I know that it will be safe because I neither overflow or go below my minimum storage target. Now, that's all very cool and interesting, but let us go one step further. How much do these overrides increase our operating costs? How many days till we're back to our original pump schedule? Of course, you already know the answer to this question. We use the Scenario Explorer tool. From the Explorer's page, we can compare our baseline to this pink load shifting scenario. We find that it used less electricity over the same week, but has a slightly lower weighted rating because it resulted in lower storage levels, which makes complete sense. Using more range in our tanks is always going to be helpful for energy savings, but it incurs risk, which all operators seek to avoid. We can also see that the storage levels align again nearly 2 days after the 12-hour shutoff began. At this point, the operator has all the information they need to create their response plan for the upcoming shutoff at this zone, all within 5 minutes. I wonder if this would be helpful to save time at any water agency today, but that's a question for a different day. Today, we have a different poll lined up for you. So we're going to start up your fourth and final poll question for this webinar. Thank you, Ali. So the question is how long it'll take for your utility to do an internal preliminary analysis of a capital improvement project. We'll go ahead and give everyone a moment to fill in the poll, and then Ali will show the results as soon as it looks like everyone's responded. Perfect. Thank you, Allie. So it looks like we have about the top, I want to say about half of the group does their internal preliminary analysis between 1 to 3 months or even longer than that. There's a gap. No one agrees that they can do in their internal analysis within a week. Otherwise, they just contract it out. So for those teams who have no ability or at least no comfort to do these internal analyses within a week, hopefully this presentation is interesting to you. Thank you, Allie. At this point in the presentation, we've hopefully demonstrated what makes WaterWatch unique. Now we will take the opportunity to demonstrate how you could use WaterWatch to save energy cost spending. In this example, let's say someone in management has access to WaterWatch and wants to quickly explore cost-saving maneuvers. Perhaps they can invest in a larger storage tank. Maybe they're interested in a variable speed drive pump. But with a pump like that, management's worried about the demand charges of their current time of use electricity rate. And they wonder if there's a better energy rate for them. You've seen many of these tools at play already, so we're going to go a bit faster. We'll start by creating a capital improvement scenario. Let's now see what the benefit would be if we increase the effective diameter of our storage tank. After naming our new scenario, we'll use the search tool in the service territory page to quickly find and zoom to the tank that I want to edit, in case I'm not already familiar. Once there, I can click on and edit the properties of any asset. In this case, I will increase the effective diameter of this storage tank significantly, say by another 100 feet. After this change was made, let's visit the SCADA Plus page to confirm that the storage tank is changed based on its fill pattern. And sure enough, we can see that the storage tank takes longer to drain and fill, reducing the filling cycle somewhat. We'll come back to this shortly to compare how we changed our system's performance, but I want to emphasize how easy it was for someone not familiar with our model to experiment with the system. Next, we'll place another variable speed drive pump at the northern pump station. Since you've already seen that being developed, I'll skip ahead a minute to where we already have that scenario made. In this case, I set the pump to fill to a much higher level than before, 21 feet, and I limited the maximum pump flow to limit the peak energy demand. However, I'm not certain that the energy rate that I currently have at this pump station is right for this pump anymore, since it will want to pump through the peak hour. So we'll introduce our energy rate comparison tool. One moment, it looks like we have a repeat of our previous crash. I'm quite excited about this. One moment, please. We are nearly there. No, we are not. Well, I'll go ahead and skip ahead just a minute to see if we can try and fix this presentation glitch. Perfect. And restarting the presentation from where we just were. Here we go. Returning to the home page, we'll open our energy rate comparison tool. This tool allows us to evaluate the energy cost of our pump stations for many different energy rates automatically for a time period of our choosing. We will use the previous month. Over the left side of the screen, we can see a list of energy rates that WaterWatch has available for various energy rate suppliers. These rates are either transcribed by our team or streamed in through the new Midas API. Due to time loss from these crashes, I'm going to skip ahead a little bit. And the point I want to get across is that this tool allows you, for every one of your pump stations, for each of these energy rates that we're streaming in, to evaluate the demand charges, consumption charges, and total costs. You can then use this tool to sort by, evaluate and explore each of these rates, learn about the demand charges, the weekend pricing, night pricing, and so forth, to take advantage of that and see if it's a good opportunity for you. For this example, let's say that we use this tool and we've selected the energy rate TOU PA3 SOP with a flat energy demand and consumption rate. We can navigate to the service territory page Select this pump station from the map and change its energy rate property to the name of that rate. The scenario is now ready for comparison with the others. For this example, let's say that we've returned every scenario from cold storage for a more complete and interesting comparison. With each scenario flagged, WaterWatch knows to compare them, and we'll move on to the Scenario Explorer page. Here's what we can see. Competing for our top scenario is our two capital improvement examples. The first was our variable speed drive pump on a new energy rate, and the second is a significantly larger storage tank. Finishing this example, let's focus on the last column of this table. Scaling to the year, we compare to the baseline, and we can assume that this water system could have saved up to $80,000 annually by utilizing this top scenario. This does not include the cost of the new variable speed pumps or additional energy costs not included in our evaluation, but are described in the energy rate documentation. However, we hope that this illustrates how someone without experience in hydraulic modeling could easily and quickly utilize this tool to leverage your hydraulic models and generate reasonable recommendations, which are insightful and meaningful for your discussions and planning. Closing out my portion of today's presentation, I hope that everyone here today has gained some insight into our new tool, which we're proud to make available for testing with interested parties. It shows great promise in its ability to extend the life of your hydraulic model to parts of your agencies beyond engineering and GIS purposes. Broadly, we hope to see a future where tools like WaterWatch help the water sector to better perform their responsibilities through collaboration by empowering a shared vocabulary and understanding of team members using the same tools who see the agency from the same perspectives. I will leave you with some hints about where we're planning to take WaterWatch next. First, we want to begin including asset management features and enable users to integrate more data sources into WaterWatch. I foresee engineering drawings naturally blending into the 3D maps or allowing for custom assets like sensors and hydrants. Second, because I architected WaterWatch to be multi-processor friendly, I know that it can be extended to allow multiple users on different computers to access and modify the same WaterWatch project simultaneously. This will eventually lead to consulting firms being able to build hydraulic models with multiple employees simultaneously, increasing the efficiency and reducing costs for future hydraulic model development. Next, we're actively working to include support for inline microhydro turbines. As an alternative to pressure regulators, water agencies could explore the feasibility of turbines directly using their historical and simulated water flows, pressures, and more for rapid and accurate siting. Leveraging WaterWatch's support for detecting pump stations, virtual DMAs, and incorporation with SCADA, we're planning to extend WaterWatch to analyze water agencies for their per zone water losses and energy intensity values. Water agencies could leverage these tools to create highly targeted conservation programs with the ability to regenerate the models and monitor their success over time. Lastly, our center is actively developing a novel pipe break model which forecasts the break frequency per pipe into the future, taking into account self-excitement, street traffic data, soil characteristics, and more. Once developed, I foresee our team building out WaterWatch to include all of these elements and allow water agencies to develop pipe replacement models as easily as they create a new pump schedule in WaterWatch today. Lastly, I want to thank everyone for taking the time to listen to my presentation, for taking the time to learn about WaterWatch, and I will hand the virtual microphone back to Kendra. Thank you, everyone.
Thanks, Robert. So as you can see, this software has a lot of value, or at least in helping water utilities explore their system. And if you would like to test it out or interested in learning more, please give us an email and we'll meet up. And what we'll do is discuss your utilities data availability and the state of your hydraulic model, possibly actually review your hydraulic model and see if you guys are ready to jump right into utilizing WaterWatch, or if we can suggest a few improvements that need to be made first. Let's see. I believe there's no more slides left, and we are just going to invite Lindsay and Dan from Molten Nagel to go ahead and turn their cameras on. And I'll get you going with a few questions. Hi, Dan and Lindsay. Thanks for joining us. So tell us a little bit about why Molten Miguel was interested in exploring this software with us. What, made you interested in joining this effort?
Yeah, that's great. I'll go ahead and take this one. So, the district is very forward thinking when it comes to looking at data and data systems. I think it was also a really great opportunity to partner with a world-class research institute to really investigate, how we can optimize not just demand management for water, but resource management and optimize resource management from that water energy perspective. We know that efficiency, well, as a very customer focused agency, we know that when we can create efficiencies in our distribution system, not just with water, but with energy, it reduces rates or keeps our ability to keep rates low well into the future. And so that's one of the things that we really try to place an emphasis on is efficiency on our side and efficiency on the customer side to ensure that rates can stay low.
Thanks. And then what has your experience been like? I mean, right now I know we're just simulating WaterWatch, and Dan, your operations team has been playing with it and doing different simulations. What has been, interesting or exciting or, in what you're doing right now and playing with it, but then also, how you see utilizing WaterWatch into the future?
Yeah, thank you, Kendra, and thank you to UC Davis for partnering with us. It's been very exciting, and really enjoyed the process of working with you guys on the WaterWatch software. As an operator, what excites me about the software is that I can open up the software, and with a click of a few buttons, I'm in there running scenarios, determining the most efficient ways that I can operate the system. And oftentimes I'm doing that in response to a shutdown or a problem with a takeout or a problem with a pump station or a reservoir being offline. And as an operator, our number one goal is to worry about capacity in the system and, prepare for the unanticipated. We can quickly determine how those activities affect storage. And, it's just a very intuitive software. It's much like just clicking around on a smartphone, very easy to use. And, as Robert showed in the demonstrations with the different color scales and everything, it's very easy to, process what you're looking at.
Great, thanks. Lindsay, how do you think you envision using WaterWatch going into the future? And maybe actually you could tell us a little bit about how your efficiency team integrates with the operational team at Molten Miguel, because I think that's kind of a unique scenario.
Yeah, sure. I can address both of those. So, one of the greatest values that we see with this software is a lot of what Robert had brought up earlier. You can look at SCADA in isolation, you can look at billing data in isolation, you can look at your energy consumption in isolation, but this tool kind of seamlessly brings all of those together. And then on top of that is this really nice platform that allows us to do those scenarios and really explore ways to optimize our system. That's helpful for me as a water efficiency manager because I help with water loss and I, oversee a lot of the auditing portions of that. We also want to look at energy intensity throughout our service area. And it's helpful for what, Dan explained, for all the different operational benefits that we can explore, whether it's outages or how outages will affect us, virtual DMAs, all those different things. And so, yeah, it hugely benefits not just one department, but many of them. And to your second question, Molten, we're big into data, we're big into financial planning, but we really have developed a culture at our district that encourages communication, that really encourages suppressing silos and working together. We've got a really great acronym that we toss around on the daily. It's called HERO. It's honesty, effort, respect, and one team. And we all work together to reinforce that as a culture every day. But we've got a lot of experience working together. I think the first thing that we really started bridging the gap on is water loss, because that really does take a village. We need our operations team, our customer service field team, water efficiency, accounting. I mean, like we have come together to manage those different systems and to do different types of improvement projects. And it's really helped us develop a rapport across those different departments and and really keep that interdisciplinary and interdepartmental work alive and strong.
Great, thanks. Anything else either one of you would like to mention about your experience with WaterWatch before we move forward?
Sure, Kendra. Robert touched on it at the very end there, but managing the leak detection department, I'm very excited about the water and energy efficiency dashboard. He touched on it very briefly there. Where we're going to be calculating mass balances in the zone, looking at inputs and outputs, and for me, really looking to manage my resources, and if I can hone in on a particular zone of the water system, and if needed, deploy the leak detection team there instead of just doing random surveys throughout our district, it'll be hugely beneficial to the district.
Yeah, it's a really exciting new development that we're about to start working on with WaterWatch. Since this is a massive software and there's always room for improvements and additions and modules. And so pressure management is our very next thing to tackle, as well as energy intensity, having a dashboard for that as well. So hopefully we'll have more results on our actual scenario testing with Molten Miguel, and that will be a completely separate webinar to showcase the actual results.
Kendra, I know you're short on time, but I wanted to add one thing that going into this project 4 years ago, I was very new to distribution and very new to all of this information as a water efficiency person, but working with you and your team has been such a wonderful experience. I felt like, we got great software out of it, but we also built a really great relationship through it too. And I appreciate the fact that, you guys were patient with us, or with me in particular. But now I really feel like I'm very empowered to go and speak to folks in my agency and work with Dan and work with our operators, and that now we have a tool that speaks all of our languages. And I know that you guys worked very hard to make it user-friendly and not just kind of in the realm of the one specialist. And so I just really appreciate all of your efforts in that space.
Great. Thanks for noticing that.
I'd like to second that. Probably the first day when we walked into that room as an operator, we come in there and we think we know the system, and we don't need anything, but as a way to gut check our feelings of what's going to happen in the system, it's hugely beneficial to be able to see it on an extended view, 5 days out, what it's going to do, instead of just normally what we do a couple days out. So appreciate your patience with us operators and getting us to see the light, which you did. So thank you very much.
Well, thanks. Those are good points. Thanks for mentioning those. I'll invite Robert back in here. We just have a few questions and we should be able to end on time. Let's see. First is, can I use this software without a hydraulic model? Which is probably a question for Robert.
At this time, no. It's the WaterWatch is built from the most basic level to basically be an advanced reader and visualizer on your existing hydraulic models. So even if it's a very, very simple, highly skeletonized model, it needs to start somewhere. In the future, we do intend to begin adding features to WaterWatch that allows you to build hydraulic models, calibrate hydraulic models, and so forth. But at this time, I would say that is the minimum threshold that you need to cross, is having a hydraulic model of any stature.
Great, thanks. And another question here, probably for you, Robert. Is this program on the cloud, and is there secure encryption of the program? Maybe Robert could answer that, and then Dan, if you want to say anything about how we ended up, utilizing WaterWatch that actually met your IT requirements and comfort.
No, it's a great question. And the short answer is none of this is on the cloud. It is not streaming or exporting your data. It is built from the start to be a Windows 10 application that natively works behind any existing firewall. So it's completely safe to install onto say a desktop or a tablet computer that's already behind your SFTP. Your IT's already done its work. You can install it there safely without worrying about your hydraulic model security.
Mm-hmm. And that, Dan, I think was really important when we were starting this and considering doing, the cloud or on-site, off-site sort of solution.
Absolutely. You guys included IT, up front early in the project to make sure that our system and our management and our IT department was very comfortable with the information you guys were accessing. And between IT and Robert, they were able to work out all the solutions.
Yeah, and we're aware that water utilities typically want, the data housed on premise. Then we have developed a way of offering this as a cloud service and in a protected environment. But we're not testing that at the moment, but it is an option into the future for those that want that. Yep. Let's see. I see if there's another question for you all. There is a question about what is our criteria for selecting prospective test systems. I think that's a question for the research center, and I would say go ahead and contact me if you want to learn more. I'm happy to discuss that more, how we go about that. And then, okay, probably our last question here, unless there's any more out there, please submit them now, is how does this scale to large water systems? So, Molten Miguel is a medium sized. Could we do this with a larger system?
Yeah, I would say yes. So currently what we presented today was one pressure zone. WaterWatch also works with the entirety of Molten Miguel's potable and reclaimed systems not shown today. So this scales up to many different cities in size, several dozen thousand. So, think 20,000, 30,000, 40,000 pipes and junctions in size of your hydraulic models. So very, very dense, very, very large hydraulic models. That should not be a problem for WaterWatch. Where you start running into some clutter is if your water system has hundreds of pumps and hundreds of valves that are all considered critical, then you're going to spend a moment basically filtering your SCADA Plus page, where you're collapsing pressure zones and organizing your assets in a way that seems intuitive for you.
Okay, great. One more question here. For water quality purposes only, can you set desired residuals and water demands, and will the model calculate that?
So at this point, the water quality components of WaterWatch are essentially in their infancy. The main call to action for this software was energy and mass balancing, where we wanted to make sure we were able to make energy load shifting recommendations that were safe and consistent. Water quality is coming soon.
Great, good answer. How long does the implementation process take roughly?
When you say implementation, I'm going to assume it's the onboarding process, where if you raise your hand and say, we're interested, we have a model, we want to go, is assuming that the model is reasonably calibrated and trustworthy, it plugs into the model within about 30 seconds. And then once you're in the model, all the pages that you saw, they're immediately available, no questions asked.
Perhaps maybe the person was asking about data integration, because we know that there's time required in adopting new softwares and integrating utility data into it.
Sure, like a training and onboarding period.
I suppose so. And just getting the data loaded in, making sure you have the right types, that sort of thing.
I would say the amount of time it takes to verify, let's call it verification. How long does it take to verify that the model was imported correctly, get everything kind of sorted and working well? Likely less than a week. Assuming that your hydraulic model is again, you reasonably understand it. You're not very confused about what kind of errors can happen with importing hydraulic models from, say, one class of hydraulic modeling tool to another class of hydraulic modeling tool. It's a very similar experience. If you've ever had to port from, say, Bentley products to an Innovize product, it'll be a similar experience.
Okay, great. Well, we're ending right on time. I don't see new questions coming in. It's 11 o'clock. So thanks, Dan. Lindsay looks like she disappeared. Thank you, Lindsay, and thanks, Robert, and everyone for joining today. We'll hope to do another webinar in the future and give a little bit more details on how we utilize this at Molten Miguel.